Well, here are the different references for the correct rigging procedures for the wings in the Supercub. This first one is per Piper Service Bulletin 910A, Service Memo number 19, and procedures for rigging a PA-18 or PA-19. And as they say here, raise the wheels up so the landing gear is off the ground, raise the tail to the height of approximate height to level flight position, and level the airplane by dropping a plumb bob from the PK screw in the top frame of the door channel to intersect a punch mark in the door rear hinge. And then you set the dihedral angle and whatnot, and washout. And this is alternate leveling procedures approved by FAA AC 4316. If the original leveling marks cannot be found, the airplane can be leveled by level the airplane laterally by placing a spirit level on top of the member that supports the front edge of the rear seat, and then place a level on either the lower door frame on the right side of the cabin or along the lower window frame on the left side of the cabin. And then if you use a digital level, you can substitute that for a spirit level. And if you use a digital level, really you don't have to level the airplane. You can set the digital level so that it's set for whatever the airplane is. It just zeroes out at whatever position the airplane is, and then all your angles and everything come off of that. I don't have a digital level, so I have to do it the old-fashioned way. Okay, well here's a diagram showing all of that. This is out of the blueprints that I found online for the L21, and then you can see here they go from this PK screw, and that goes down to the lower door hinge right there. A dimple in the lower door hinge, a punch mark in the rear enclosure door hinge. So that's instructions there out of the diagrams. Anyway, that's all the instructions I printed out, I guess. But that's enough to do what I need to do. The first thing we want to adjust here is the dihedral. And the dihedral is how much the wing tips are above the plane of where they attach to the fuselage. And why is dihedral important, you might ask, or why would you want dihedral? Well, there's a couple pretty good reasons for that. If you had a flat plane, if the wing just came out flat from the fuselage and straight out, that you would think would be ideal. That would be the most efficient way for the airplane to fly. It would get the best fuel consumption and the highest speed. But it has some characteristics. The main one is that it's statically stable. You might think statically stable would be a good thing. It sounds like a good thing. What it means is the airplane stays in whatever position that it's set at. So it means if you're in level flight, it would stay in level flight with the wings level. It stays in whatever position you put it in. If you turn it at an angle, if you pick one wing up to turn and the other wing is down for the turn, then it's going to stay in that position when you release the controls. And you think that might be a desirable characteristic, but what happens there is that when you're flying along, if you hit a little bit of turbulence, a gust, usually a gust or turbulence hits one wing more than the other one, or you'll have up turbulence under one wing and down turbulence under the other one, then it'll lift one wing up and the other one will go down, and it'll have a tendency to stay in that position. So a pilot has to be constantly adjusting the stick, has to be constantly flying the airplane. It's just a constant movement all the time. So if we raise the outboard ends of the wings up above where the attach point is, the way aerodynamics works, when one wing goes down, it winds up getting more lift underneath that outboard end, and so it winds up wanting to pick that outboard end up, and the wing that goes up in the air higher, as it's going up, it's decreasing lift, so it wants to come back down. So you have what's called dynamic stability. The airplane wants to revert back to level flight, or whatever flight position that it's put in, if it's a stable position. So if you go up to like a 10-degree bank, maybe more depending on the airplane's going to want to come back into level flight. Once you get over into a 30-degree angle of bank or so, then it gets stable again and it stays in the position. But it'll stay in that position, and if it goes over, it'll want to come back to that position. Well, anyway, that's why we want dihedral, and that's the first thing we want to check. There's two ways of checking the dihedral, And the first way is to run a string line from wingtip to wingtip over the top of the front spar. I've done that. I've got string line there going from wingtip to wingtip over the front spar. And then you come over here to the hinge points where the spar attaches to the fuselage and measure the distance from that hinge up to that string line, and it just happens to be 3 1/8 inch is what it's supposed to be. So that's what I'm going to do. I've got 2 7/8 of an inch here on this left wing and right at 3 inches on the right wing, so I can screw those struts out a little bit to adjust that up to get the right dimension there. Now there's a second way they say you can test that, and I've set up for that too. And the second way that you test that is to take a 30-inch level, and I thought I had a 30-inch level, but when I got to looking at them, I've got a 28-inch level, 24-inch levels, and this 48-inch level. Oh, in the instructions here, and of course it's common sense, it says you can use a 48-inch level to substitute for a 30-inch level. But what you do is at a 30-inch point, you take a 3/8 inch shim, so you hold this end up, the free end of the beam up, to the inboard section of the wing, and they recommend being out there somewhere between where the jury strut attaches and where the main strut attaches. Anyway, you hold one end up, the free end up to the inboard section, and this 3/8 of an inch shim up to the outboard section right underneath the spar, and you adjust the wing until you get level on your bubble level. Now, that just so happens to be the same way that you adjust the washout using that on the wingtip. You use the same procedure. So I've set up a 48-inch level here. That's a 3/8 inch piece of aluminum tubing, and I've got it hot glued down there right at the 30-inch point. So I can use that for either adjusting the dihedral or adjusting the washout. But we've got set up now for the dihedral. Oh, we'll get busy and get that done. I've tightened the lift straps back up there, took the weight off the struts and took the pins out of them. I took a piece of safety wire and hung the struts up from their respective anchor points there to hold them in place. And now I can use those straps to raise that wing up till I get the proper dihedral. And then once I do that, then I can adjust that forward strut out until it lines up with the hole. I've got both these wings adjusted, the dihedral. I'll put this level on here on that spar. And that's perfect according to that. And the other side is almost identical to it. The left side is, or the right side is identical to it. And that's just exactly the way the paper says to do it, except that this doesn't come out. This is 3 1/2 inches there, supposed to be 3 1/8. And on the right wing, it's almost 3 3/4, 3 5/8. So I'm not sure exactly what to do now. I'm going to call Jim and see what he's got to say. Well, I just got off the phone with the mechanic. Actually, I just got up from the chair having a bite to eat. My wife made me a sandwich and I just brought it out here and had a little bite to eat. But before that, I was on the phone with the mechanic talking to him about this question with the dihedral on the wings, the difference between what I'm measuring on the string up there and what I'm getting with bubble level. And he suggested I go with the string. So that means this right wing is a little bit high. So I'm going to go ahead and take the pin out of that and screw that one in a little bit and see about getting those measurements down a little bit. Now the thing is, if I bring down this right wing a little bit and that string measurement comes down there on that wing root on the right wing, it's going to come down on the left wing to a degree too. So I have to figure that out. But that's what I'm going to do now. I hoped I was done with it. I just took and gobbed a whole bunch of peralkatone on both of those and that fitting, but I've still just got them held in there with those lineup pins that I made, those little bullets, so it's easy to get it out of there. I just took the weight off of it with that strap, and I can get to work back on that. Well, it took some fiddling around. I had to drop that right strut down a few times, and then I had to raise this left strut up a couple of times, but I finally got it to where it's within a 1/16 of an inch there on that string line on both sides. It's pretty close. I checked it with the bubble level method again after I got all done, and this left wing checks out perfect, and the right wing says it's a little bit low there on that outboard side, but it's showing perfect with the string method here, so I'm going to go with that. That's what the boss said, so that's what we did. Well, now we get to fool around with it some more and try to do the washout.